Okay, well, thank you very much for coming. So thank you very much for coming. And yes, I got an email list for the attendees, and I sent everybody an invite to the training portal so you can download all the applications that we are going to play with here, right? So just check your email. You should have received an email, a subject called Welcome to 7A Security Training. And then basically you just click on the link and just register. You have access to everything forever, right? So for workshops, we do this for courses, for paid courses, but for workshops is also the same. You get free access forever. So whenever we update this workshop, you will get the updates. You keep access to the recordings, the vulnerable applications, the slides, and all that. Okay, so yeah, and if you watch this later, if this is like pushed to YouTube or something, just email admin@7asecurity.com and we can just give you access. That's fine. So we can give you access for free. If you couldn't make it and you watch this later, just email admin@7asecurity.com and say something about providing access to this, and there's no problem with that. Let's get started, and I will keep an eye on the chat on Discord, right? So we are going to use the workshop channel for this. So if you have any questions, please type them there because I will not be able to see them on the Zoom chat. So please type them instead on Discord channel because I have like a second monitor here where I can see that. Okay, so I'm going to show you first a very quick overview about the course. Like, well, everybody, like, while I do this, ideally you should like start to register and all this so that you have access and all that stuff. So that when we get to the demos, I will do the demo first, but then I will give you like a few minutes so that you practice the demo by yourself. And then you can like ask any questions that you have. This will give you a little bit of time while you register and all that, and then we will jump into the topic, right? So I think the introduction already cleared this, so I'm not going to spend a lot of time. So I'm the CEO of 7A Security, deliver training at Black Hat USA, Hack in the Box, and all these other events. You can see upcoming trainings here. I also wrote a course for Electron Security. We also have our own courses at 7A Security. I was for the LTF project leader. There's other presentations in this link. And then if we meet someday over a beer, I can tell you how all these like certification madness happened. Okay, so with that out of the way, if you're interested in this workshop, you might find public reports interesting as well. So these are all available for free. This one in particular, it's more about mobile security, but it was pretty cool. Basically, in South Korea, there was an application that was mandated on the country level. So every father was obliged by law to install this mobile app and the child as well. And then the parent would control with their parent application what the child was supposed to do, right? Like what hours should the child use the phone, what websites could they visit, and all that stuff. So there were a lot of security problems with that. And if you are interested in that, there's 2 public reports. There's also a YouTube presentation. The slides are here, so this is all public, and this is some of the work that we did. And then there's some stuff about the Chinese government capturing data about Muslim minorities and stuff. So these are more kind of privacy related, but if you're interested in that kind of stuff, those are the links to those public reports. All this stuff is available for free. And if you take our mobile course, all these applications are part of the mobile course. So you can play with the apps and all that. So this other public reports. And now this course was also, so the workshop that I'm going to do today is like a brief overview of some of the course that we have about desktop, the hacking modern desktop applications. So I'm not the only author. Another author is Anirudh Anand, and he's security researcher focused on web and mobile application security. He loves CTFs. He's a member of the Team BIOS, which is the #1 ranked team in India. Occasionally, he does bug bounty hunting on Google. He has found vulnerabilities on Google, Microsoft, LinkedIn, and many others. He also has some nice certifications, OSCP, OSWE, EPWD. This is his blog and his Twitter, so just to mention him as well, even though he's not here today. And now I would also like to give props to these guys because these are my co-workers from Cure 53. I still collaborate a lot with Cure 53. Basically, these 3 guys made the course much better by answering my questions, right? So as I was writing the course, I was asking these guys about certain topics, so that made the course a lot more awesome than it would have been me alone, right? So I just want to give them props. Okay, so So for the course itself, these are the requirements. If anybody gets the course, right? So we provide like the lab VMs, the test applications. Everybody gets lifetime access to the training portal, including all future updates, step-by-step video recording slides, lab PDFs, and there's unlimited email support as well, and the source code of the test application. So all this is standard for all courses, and this is also standard for these workshops. So whenever we update this workshop, we upgrade the vulnerable applications. If we make this workshop like 4 hours instead of 2 hours, and there's a lot more content, you will get all those updates for free as well. So this applies to this workshop. With that, I'm just going to give a quick overview about, so that you see how this workshop falls into the course itself very quickly, and then we will move on to the first demos and all that. So first, we start with an introduction to Electron. So we are going to look at some of this stuff today. We will skip the reversing of Electron binaries, but we will looking at the package JSON and web preferences. So we will do a little bit of this today. We will also do a little bit of XSS and remote code execution essentials on Electron applications. And we will also take a look at electronegativity. So we will check some of this stuff today, not everything, but some of these topics. And then in lab 2, we look at XSS and remote code execution. Now, of course, we cannot cover the entire lab in the workshop, but there will be some of these topics will be covered in this workshop as well. So today we will attack preload scripts. I will go into what that is and all that in a moment. CSP bypasses are covered in the course alone, I think. And then we will also take a very brief look about remote code execution in Windows and stuff, right? So will be part of the talk. I think these we will not cover today. But just to mention that in the course, we also take a look at like local data leaks and stuff like this. And we cover like the 3 main desktop application platforms. So we cover Windows, Linux, and Mac OS. We will also not look today at the art of man in the middle. So this is another of the labs in the course. So this basically looks at how to man in the middle modern desktop applications. So yeah, so we just go into a number of techniques about how to do this. Then we also modify the applications themselves. Now we won't do this, but we will have some Linux reverse shell in a different way today. Yeah, but just to mention that there's like other stuff right in the course that we cannot cover today. And then in the instrumentation lab, we talk about using Frida, all this. And all these techniques are useful. Like you can use Frida, for example. Frida is like super useful. You can use it on Android, iOS, Windows, Linux, Mac OS 10. So you can pretty much use it on everything. And it's really cool because it allows you to see what the application is doing at runtime. This is what we call instrumentation. So we have an entire lab dedicated to this. So all this stuff actually works, all these techniques like Frida Trace, Frida Discover, all this stuff works not just against desktop applications, but also against mobile applications. And then the last 2 methods like DevTron and Chrome Inspect, these are more kind of Electron specific, and they give us insight into other stuff in Electron. So these are all the things that are covered. Then they finishes with a CTF, and in the CTF there's like some open challenges for you to like test your skills and play with other real applications and stuff. Then in part 2 is like the more advanced part, and we will look at some of those topics today. So first we look at attacking like Electron apps on Windows. There's some interesting things on attacking Windows, like how to get remote code execution without warnings, how to bypass CSP using file URLs and other stuff like this. So there's a lot of cool stuff like that. Then there's another interesting topic with XSS is data exfiltration, right? Because sometimes if you get XSS on a desktop application, you can use the XSS to like steal local files and send them to an attacker, right? So we cover that in some of the labs. And today we will also look at some of these aspects. Then there's another lab about VPC remote code execution. So this is interesting because sometimes there is, well, I'll go into this later as I do the demo and stuff, because now maybe it won't make sense, but this is just to say it's pretty cool. So yeah, we actually are using like real applications, stuff found in real pentests. So whenever the pentest is not public, we take a vulnerability that we have seen in a real pentest and implement it in a custom-made like application. But all the vulnerabilities in this course are real vulnerabilities found in real applications. And I think today we will use 3 or 4 vulnerable apps. So all the vulnerabilities that we're going to cover today in the demos and everything, they are all like real. They have been found in real applications and stuff, right? So yeah, IPC and middle click remote code execution and stuff like this. We will look at some of this stuff today as well. Then more man in the middle, real applications and stuff, remote attacks. This is really cool, right? Because you think hacking desktop applications and stuff, and you think about Electron, and of course, a lot of the stuff in the course and some of the things that we're going to see today also applies to other things, right? Because now you have JavaScript stuff, like you have mobile applications written in JavaScript, right? You have applications written in JavaScript for Android, for iOS, and some of the techniques that we're going to see today, you can also apply to these mobile applications. But you can also have these like desktop applications on the server, right? So we had this pen test where there was an Electron application that was being run on the server to turn user-supplied HTML into a PDF. And in this lab, we go through like how to fingerprint first, is what the server is doing and stuff, and then how to attack the parser and all this. And then given that it's Electron, like how to attack that, right? So this is a pretty cool attack on that. And then there's another lab on local attacks with privilege escalation and all the stuff, right? And then at the end, another TTF. So with that, hopefully I gave everybody enough time to register to the training portal. And now we're going to start with the actual content of the workshop today. Okay, so let's talk about hacking modern desktop applications with XSS and remote code execution. So first thing to know is in Electron, we have a main process, and then we have a renderer process, right? The main process, the main thing to remember to understand this workshop is that the main process has a lot more privileges than the renderer process, right? So the renderer process, you can shield it more, you can like trick the permissions and stuff, and it's kind of more difficult to attack. But sometimes, because the render process talks to the main process, you can, using an XSS in the render process, you can communicate to the main process and attack other things and gain more access, right? So we will look at some of that today, some example, right? So how does this work, right? So Electron applications are written in JavaScript, and this is all using the Google C8 engine, right? Similar, it's all based like on Node.js. So by learning how to attack Electron applications, this knowledge will also be useful to attack Node.js web applications. And some of this knowledge will also be useful to attack mobile applications written in JavaScript, for example, right? So all these kind of overlaps, right? So it's really more modern desktop applications, but because it's JavaScript, a lot of the techniques and concepts apply to other things. But in Electron specifically, you have the kernel right at the bottom. So you have Windows, Mac, or Linux and the operating system, and this does like its own thing, file writing and all this. Electron's core talks to the kernel, and then there's a communication here, right? So you have the main process, the renderer process, and they can communicate. They can send messages to each other and do things, right? So the renderer process can tell the main process to do something and the other way around. And then this API calls to Electron from these processes to do stuff, right? So this is at a high level how things look. As I said before, the main process can do more stuff, right? So because it is more powerful and it can do more stuff, this means if we can somehow reach the main process, this is going to give us more privileges, right? And we will be able to do more damage. There's a little bit of overlap, but in general, the main process more powerful, more damage, right? So that is the idea. So now let's look at essential techniques to audit Electron applications. So what we're going to look at now is just a quick way to get you started, right? Because let's say you're giving an Electron application, you have never tested an Electron application in your life, right? So what do you do? A quick way to get started is to look for vulnerabilities in the packages, right? Because now you have like this huge application that is written in Electron, and this is true like for Node.js applications as well. And the actual application code is like this small, right? But then if you take into account all the dependencies, it's like huge, right? And this is good, right? Because the more code you reuse, the less likely the developer is going to be to make a mistake. But at the same time, if a vulnerability is found in one of the libraries you're using and the vulnerability is public and you did not update this dependency, then this can lead to issues, right? So for all JavaScript applications, now you can do this against Node.js, you can do this against Electron, you can do this against Apache Cordova applications for Android or iOS. anything that is written in JavaScript and uses npm, you can use this technique. You can just type npm audit, and this will try to find vulnerabilities in the dependencies, right? So if you are on the training portal, I'll give you a few minutes. At the end, maybe we will do 10, 15-minute break, something like this, depending on how we're doing on time, for you to practice this. So on this slide, this is where you have the link to download this. In this case, this is actually public, so you can go to the GitHub and download it. So you can follow these steps either as I'm talking or at the end, because I'm also going to do the demo so that you can see these steps being done in practice real time. So this will give you a little bit more of an idea about how this works in practice. But the main thing is the first time you run npm audit, you're likely to see this error. So as always, read the manual, right? It's the typical thing that whenever you ask something in a forum, everybody's going to tell you read the manual. A little bit less politely that I have just said probably. And in here, you can just pay attention to the error message, right? So whenever you run npm audit, you are very likely to encounter this error, and the error is telling you what to do. It's telling you try creating one first with npm I package log only, right? So you do this npm I package log only, and what this is going to do is an npm command that is going to look into all the dependencies, right? Because first, the npm audit is going to look at the vulnerable versions, but first, you need to resolve all the dependencies, because you can have a dependency that has another dependency, right? So all these tree of dependencies has to be resolved, and this is what this command is going to do. It's going to create a package log only, a package log JSON file that then npm audit will use for the audit itself. So basically, you just run this command, and then you run npm audit, and this is going to give you like some findings about vulnerable stuff, right? So I'll just show this now in the demo in a moment. And the important thing to note here is that even a perfectly secure application could become vulnerable down the line, as issues in underlying libraries are found over the years, right? So if you have a perfect application, but then like you never update it, and 5 years later something comes up in some of the underlying libraries, then this application could become vulnerable. Okay. Another thing to look at, and this is more specific to Electron applications, is to look at the package JSON. Now, this one, to download this, you need to be logged into the training portal. So I gave access to everybody. If you are somehow in this workshop and you were not part of the attendee list, email list that I was given before, just send an email to admin@7security.com and I'll give you an invite. Now, while we have a little break at the end of the demo, I'll take a look at email and see if I have to invite anybody. But yeah, to download this, you need to be logged in. So what we need to check here is the package JSON file. This file is going to tell us which is the main entry point, right? So here we're looking for main, and in this case, main is called main.js. So this is the main entry point for the Electron application. So this is going to tell us the flow about how the application works. And the most important thing when you are reviewing the configuration of an Electron application is to look at the web preferences, right? So in web preferences, the two most important security settings are these two here: node integration and context isolation. And these are the insecure settings, right? So let me elaborate on that. So node integration is enabled, and this is bad. Why? Electron is based on Node.js, as I said before. So when you have node integration enabled, this means that any XSS that you get on the desktop application is going to be automatically remote code execution. And we will see this in the second demo, I think. And then, so this is why this is bad, right? So node integration set to true is dangerous because any XSS we find on the desktop application will become remote code execution. Then context isolation is disabled, and this is also bad, right? So in this case, we have a bad setting, which is false instead of true, right? But why is this bad? Because if there is no context isolation, the preload script can expose certain things that when you get XSS on the renderer process, we can modify JavaScript to, for example, get access to some of the stuff in the preload script. I will elaborate on this a little bit later, and we will also have a demo about it. So we will attack both of these two bad settings in the demos, and this will make a little bit more sense. But for now, let's say these two settings are bad, right? They are bad for security. So does anybody see a problem with this code? Can you type on the Discord channel, the workshop Discord channel, if you see a problem with this? Any takers? Does anybody see a problem in this little piece of code? Nobody? Come on, it's easy. I'll give you 5 more seconds. Any takers? I see nothing on Discord. Yeah, I think it's better if on Discord because I have Discord open here. So no sanitization, yes, there's no sanitization, but why why is it bad? Why is not having sanitization here bad? Or how does it lead to a problem? Screenshot of the slide. Okay, so I'll tell you what the problem is. So the problem is that user input is assigned to JavaScript sync, right? So when you are talking about tainted analysis, you talk about sources, which is where user input comes from, and sinks, which is sensitive place that can lead to security problems where user input ends, right? So in this case, we have the message, which is whatever the user typed, being assigned into inner HTML. So this is bad because it's basically XSS. And of course, there's a lot of other ways in which this could happen. And a good list of DOM XSS things can be found in the DOM XSS wiki. I think this has not been updated for a while, but it is still a pretty good comprehensive resource about JavaScript syncs. So for the most part, it's still very relevant. Yeah, so you have a full list here, but inner HTML is an XSS sync. So whenever you assign user input to inner HTML or location, or you do document write user input, and a lot of other things like that in JavaScript, these will result in XSS, right? So that is how you would look for vulnerabilities at the source code level. And now talk about electronegativity. Okay, so throughout the labs in the course, you're encouraged to use electronegativity. If you have no idea about how to audit an Electron application, this is also a great way to get you started because it will give you a lot of low-hanging fruits, a lot of problems in the configuration, and it will also give you links to attack certain things or ideas for attacks, right? So you can install it very easily if you just do npm install and then add doyansec electronegativity, and then that's G is important because you want to install it globally on your system so that you can run it from anywhere in the path, right? Without like installing it as a local application. So that's G is important. And basically just do electronegativity and then -I and the folder where the vulnerable application is or where it has been extracted. And this will do an analysis and will look for a lot of possible security problems. Most of them are configuration based. And in here, you will notice like a lot of things, right? So you will see like exactly the name of the file, the lines in which this finding is kind of relevant or where the problem was found. So it gives you the file, full path to the file, the lines of code where the problem is, and then you have a link with more information about what this finding is, right? So very useful to get you started. Now, this will not all necessarily be a security problem, but it's a good way to get you started, right? Especially if you have no idea. You just run this and you have like some pointers, right, to look at. So this is just some example output. And with this, I'm going to jump to the demo. So let me share, where is this? Here. Let me share this. So can you see this? Can you see my screen? If you can type on the Discord channel, the workshop Discord channel, everybody sees my screen fine? Cool. Okay, so this is what I explained during the slides. So we do npm audit, right? You get this error message the first time, right? And this is telling you, try creating one first, right? So it's telling you there is no package log JSON found, right? So the dependency tree has not been resolved, right? Like what I explained before, like you have an application, and then this application is using a library, and then this library uses another library that uses another library that uses another library, right? So you need to resolve all that, and this takes like a few minutes. So I skipped it here. So you just copy it from the message and paste it, right? Which is what I did. And here we can see the output of this, right? So this is like running for a little while, and then at the end, it gives you already a summary of the vulnerability. So one low, one high, two criticals. And now what I'm going to do is run npm audit, which will be quicker because the tree of dependencies has already been resolved. So this is one of the exercises for you now when we do the break, right? I'm just doing it now, but this is all hands-on, right? So we will take like a, I don't know, 10-minute break or something for you to play with this one, right? So you do npm audit, and then this is doing the analysis, and you can see the output, right? So this is going to tell you, okay, there's a critical issue, remote code execution on the Electron version, and then you have more information in these links here, right? So you have all that stuff. So this is a very good way to get started. And as I said, this is a very simple thing to do, right? So you just do npm audit, and this is something that will not only work against Electron applications, this works against almost any JavaScript application, right? Node.js web applications, Apache Cordova, PhoneGap, Ionic, React, anything written in JavaScript, you can do npm audit, and this will give you some pointers, right? So if you cannot find something or you're kind of new and learning, so this is a quick way for you to find vulnerabilities and then click on the links, look for the advisories. Maybe sometimes in the advisory, you will have some proof of concept so you can learn what the problem was, see how the exploit looked like and all that stuff. So this is a very easy way for you to get started, right? So one very quick tip, right? Just run this little command, npm audit, and this will be super useful against anything written in JavaScript, right? So that's the first tip. And now this is more Electron specific, right? So you have an Electron application. You can see this is the vulnerable one application, which is in the training portal, where hopefully everybody has registered already. And if you download it, right, and you unzip it, you will see these files, right? So from these files, the first file you want to look at is package.json. So I'm going to open this with VI. In here, you want to look at this, right? So you have main, and this is called main.js. So main always defines the entry point. So the first file that will be loaded in this Electron application. So in this case is main.js. So we have to open main.js. And here you're looking for browser window, right? Browser window, whenever you do in Electron new browser window, you are creating a new render process, right? So you remember my slides before, I was talking about there's a main process and a renderer process. So the main.js is the main process, and the main process is creating a renderer process each time you do new browser window. So whenever you are auditing an Electron application, you should look for this. You should look for new browser window because this is the place where usually you will have the preferences, right? So web preferences are going to be the security settings applied to this browser window or this renderer process. And in this case, we have two bad things, right? So we have node integration set to true, which means XSS against the desktop application, if present, will result in remote code execution automatically, right? So we don't need anything else. If we have node integration set to true, any XSS automatically is code execution. And then the next bad setting that we have is context isolation set to false, right? We will attack this later, but basically this allows us to attack preload scripts, okay? So yeah, so we have all that. And now let's look at the render vulnerability. So in here we have a render.js file. And as I mentioned, we have the vulnerability here that inner HTML is assigned to message. We will actually, I think, attack this on the next demo. Okay, and now let's test electronegativity. So you have electronegativity, and then you do -i and the directory where the application was decompiled or zipped if you have source code. So in this case, I'm hitting enter on this, and I'm running electronegativity. So this is doing the checks. Here we have the output of this, right? So there's 42 checks, and here we have like a lot of problems. Of course, this is a vulnerable app for learning that is implementing issues that we found in real pen tests, but very easy way for you to already start finding problems, right? You will see here there's some things where it says review required. So some things are tentative. It's not necessarily, so these are not necessarily all security issues, but still it gives you like a lot of pointers about stuff to read more about, if it is a problem specifically on this application or not, and all that, right? Because for example, can have node integration set to true, and I can tell you all day that this is bad. But if the application has no XSS, you can do nothing with this, right? Because first you need XSS. And then well, the problem is this makes XSS code execution. But if there's no XSS on the application, specifically if the application is written in React Native, right, it's difficult usually for people to shoot themselves on the foot because on React Native, on React applications, you have to do dangerously set inner HTML equals to user input, right? So you need to do something like that. So it's more difficult, right? If people are using React Native to have React to have XSS, right? So this is bad, but you need XSS, okay? So this is the XSS and this is electronegativity. So with this, I think that's enough for the demo. So now I'll give you like 10 minutes to play with this. So just go back here on the slides, right? To this slide about finding vulnerabilities in dependencies and try to do this. Let's wait maybe 10 minutes. Or if you want to continue quicker, just let me know. But maybe 10 minutes is enough for this. Sounds good? Yeah, so we make it more hands-on. It's not just me talking. Okay? And I'll keep an eye on the chat. Sounds good? I'll be back in 10 minutes, but I'm keeping an eye on the chat. So if anybody has any questions in the meantime, or anybody wants to ask anything, just feel free to do so. I'm especially looking at the workshop channel on Discord. So please type your questions in there and be happy to answer. There's no questions so far? Okay, see a couple of people with problems with access, so I'm going to fix that. But if there's any questions, please type them on the workshop channel. And let's give like 10 minutes for you to practice this, and then we will move on to the next demo and stuff. Problem with that. Okay, so now let's continue with what XSS means in a desktop application and how to turn XSS into remote code execution, right? So can everybody hear me, see my screen and everything else? No questions on the stuff before? Can you guys hear me? Can you type something on the Discord channel? Awesome. Okay, so then let's move on. How to turn XSS into remote command execution, right? So now for this one, you need to download the vulnerable one application, right? And when you unzip the file, you need to run this command first, right? So to actually start the app, you do npm start, but first you need to do npm install because this is going to install the dependencies, and every Electron application has a dependency called Electron, right? So every Electron application depends on the Electron dependency by definition, and Electron depends on Node.js, and there's all these dependencies, right? So when you run an app, when you unzip the source code of an app, first you always need to do this npm install, because if you do npm start, it's going to fail, saying that there's no dependencies are not installed and it cannot start, right? So just a quick note about that, because you will likely run into this problem, right? You cannot do npm start directly, you need to do npm install first, right? So just when I will do the demo at the end, but when you follow the steps, just pay attention to that so that you don't run into that problem. Now, another cool thing about Electron applications is that you can do like view and toggle development tools. Sometimes the application will hide the menu because it doesn't look too pretty, right? but you can still use the keyboard shortcut, right? So you can do like Control Shift I, and I think on the Mac is Command Shift I. So on the Mac, usually everything that is Control is Command, so it's a different key. But basically, by running this keyboard combination, you can open the developer tools, and this will in turn allow you to inspect a lot more what is going on, what the HTML looks like, what the error was if you're trying to exploit some XSS problem, right? So this is all like very interesting stuff, right? So you can try some payloads. For example, you can try test script alert one, test SVG on load alert one. So these are all like common XSS payloads, but you will notice they will not execute. Why is that, right? So you can check with the development tools, right? Which is explain how to open them before. You will see that when you send yourself a message with this vulnerable application, we have XSS, but the XSS doesn't run, right? So this is actually because this is part of the RFC, right? Because the HTML page had already been loaded, right? This is a DOM XSS. So when you have a DOM XSS, you cannot usually inject script or SVG on load one, that things like that will not run. So we need a different type of XSS. Still possible, but these payloads will not work, but this is why, right? So instead of that, you do image source X on error alert one. Now you're forcing the browser to render an image. So it will try to load the image. The image has a source of X. X doesn't exist, and therefore the on error event handler will fire. And here you can have alert one. So if you just send yourself a message like test image source X on error alert one, then this will pop out, right? So we have on the development tools, we still see that the HTML has been rendered, but we get alert one, right? So as I explained before, this application has node integration enabled. So this means with this XSS, we can access all the Node.js functionality, which means we have remote code execution. So we can run the calculator app, or so if you are on Windows, this is Calc. If you are on Linux, maybe if it is Genome, it is going to be the Genome calculator. On the Mac, you have to use the full path to the calculator app, but it works like the same command exactly. And then you can also run other commands. You can run id, ls-l, uname-a, whatever you want. You can like run any commands you want, right? So with this, we are turning XSS into remote code execution, right? So things start to get more exciting, right? Everybody likes shells and stuff like this. So yeah, you just do this, and now an XSS now turns from alert one into the output of the ID command, right? So it's becoming more scary, right? So and this is all because of the node integration setting, right? Because node integration is enabled, any XSS leads to remote code execution, right? So the way to fix this, now this goes into the way to fix this, right? So you should use like defense in depth, right? Try to have like multiple layers of defense. So the first layer would be to have no integration to false. And now, even though you might still have XSS, at least it's not code execution. So that's already an improvement. And then when you try to run the same payload, you will see there's an error message on the development console saying that require is not defined, right? So this means that we are no longer able to invoke Node.js functionality from XSS, right? And then another thing that you can do is to use CSP, right? So CSP is going to make exploitation of XSS issues more difficult. Then we will also try to bypass it in some labs during the course itself, but this is just another for you to do this, right? So you have like image or text on error alert one is still working. Then if you implement the security policy, right, like this, for example, close the app and run it again and try this image source text on error alert one, you will notice that you get this error message. Refuse to execute inline event handler because it violates the following content security policy directive, blah, 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 right? So basically, when you do that, you will notice that this no longer works, right? So this is another layer of the defense, right? And then, of course, we also need to fix the XSS itself, right? So even though we have CSP, we have disabled node integration, we should also fix the actual XSS so there's no XSS anymore. So you can avoid XSS sinks. So for example, we can change inner HTML from inner HTML to text content. So even though we are assigning user input, even if we don't validate anything, just by doing this, this will no longer be exploitable, right? Because text content is not a DOM XSS sync, right? It's the same as avoiding SQL injection, right? If you are not concatenated into a SQL query, if you're using bind variables, there's no longer this concatenation, so you no longer have SQL injection. So here with XSS is the same thing. If we change an inner HTML sync to something that is not a sync, then there's no XSS anymore. Now, if we try the same payload, you will notice that the payload is rendered as entered. And if you look in the development tools how this payload looks like, you will notice that all the HTML characters have been encoded, right? So basically, this shows you that, yeah, this is pretty much fixed, right? And then sometimes, of course, you still need to support some XSS somehow. So not support XSS, but have to support HTML, right, in user input somehow. Sometimes you need to do this in some forums, for example. You need to allow users to put like some letters in bold, italics, all that kind of stuff. So in those cases, you can use a library designed for that purpose, right? So you can use, for example, DOM Purify, and this will look at the HTML and try to turn it into something safe, right? So this is the way to install DOM Purify. So you will add the dependency, and then you can use it to sanitize unsafe HTML to turn it into safe HTML, right? So you have DOM Purify require DOM Purify, and then the renderer file we can do this, right? So we can comment the other lines, and then we can do the output is inner HTML equals DOM purify sanitize message, right? So this will allow HTML, but it will not allow XSS, right? Now, of course, sometimes there's vulnerabilities in these libraries, but this is rare, right? So this is like much better than rolling your own solution for sure, right? Because when you roll your own solution, it's much easier for you to make mistakes. But if you use a library that has been used for a long time and everybody has been trying to find two bypasses on this for a long time, it's going to be very difficult to bypass, right? Then every time you change the app, you need to close it again and then run npm start, and then you can see the difference, right? So if you try now these payloads, you will notice that they don't work anymore, right? So this is just for mitigation. We have like almost an hour left, so I'll try to do the demo a little bit quicker. So let me see here. I'm going to share now. I think I'll share, wait, because this one, yes, this is vulnerable one. Okay, so I'm going to share, I'm just trying to check. Yeah, it seems I'm sharing the VM now, right? Okay, so can you see my screen? Cool. Is that big enough? Can you read like the letters? Can you read npm start? Okay. Okay, I'll make it a little bit bigger. But anyway, this is not the important part, but this is how you start the app, right? So first you will need to do npm install. Just remember that when you do this exercise. So we do npm start, right? And this is the vulnerable application, okay? So now in here, I can try the payloads that I was mentioning. So I can try, now since this is Linux, I'm going to try the Linux payloads, right? So I'm going to copy all this. I have a link for this for easy copy paste from the slides as well. So I can paste all the payloads in here, right? So this is simulates a chat application, right? But you're just sending messages to yourself for testing. But these are all like vulnerabilities found in real tests. I'm not sure if this will work. I think it seems to be a bit bigger. Okay. So okay, so now I'm going to send this message, right? And we have four broken images. So this is the output of the ID command. The genome calculator will take a little bit longer. yeah, this is the output of some of the other commands, and this is the ls command, right? So you can see that we can read like which files are present on the directory, and then we can like cut these files and other stuff. So we can run commands. This is the output of the uname-a command, right? So we have code execution, right? Because in here, let me see. In here, if I inspect this, right, you can see that all this has not been sanitized at all. So whatever I've typed in here, it has been added here, okay? So yeah, so since we actually don't have, I have like a lot more demos to go through, I think I'm going to give you, let's say, 5 minutes for this one, right? You don't have to do like all the mitigation if you don't want to, and then just give this one a shot, and then we will move on to other stuff. Okay, but you can just from the slides. Let me go back to the slides. Slides. So from the slides, you're supposed to start in this case from here, right? Yeah. So from this slide, basics of Electron XSS exploitation. So just follow the steps from here. And if you have any problems, just ask in the chat. So let's give like around 5 minutes for this, and then we will move on to the rest so we have time to cover some other cool stuff. And in the meantime, if anybody has joined afterwards, just email admin@7esecurity.com for access, and I'll give you access. Okay, so I see there's a few emails, so I'm going to go through those. Yeah, just let me know if you have any questions about anything we've covered so far as well. And yeah, I'm going to give access to some people here. Okay, so any questions so far? Because I have a lot more content. Maybe this should be a 4-hour workshop. No questions? I see no questions on Discord, on the chat here. Oh, there's something on the chat here, wait. Yeah, so I got a few emails for access, so all those were sent. If somebody has trouble, just email me back. I noticed a couple of people had trouble with access. There was some weird stuff like going back to the login page. So just in those cases, we're investigating that. I'm not sure why that happens, but it will be fixed today, I think. Okay, so let's move on to attacking preload scripts, right? So now again, if you didn't have time to do the other exercises, don't worry because this is all recorded. You have access to all these for life, and you will be able like to download the apps and all these like at your own pace. So this is all fine, right? So now for this one, we are going to use the vulnerable 2 app. And what we are going to do here is to attack the other security setting that we were talking about before, right? Context isolation. So this is a slide from Masato, who is a Japanese security researcher, really good, one of my friends from Cure 53. And in here, we can see in this slide, he explained it really well, right? So you have a preload script and you have index.html. So the preload script is a script that, wait, let me see. Are you seeing? Yeah, you see my slide, right? Yeah. Okay. So yeah, so the preload script runs with the privileges of the main process, right? So it has like, let's say, more access, right? It has access to Electron functionality, for example, and then the security. So for example, if you set node integration to no, right? So if you have an XSS on index.html, which is going to be run by the renderer process, in here you will not have the ability to have code execution. But if there is no context isolation, you can still do some stuff to attack the preload script, right? So this is what we're going to look at. So when there is no isolation, which is what we will be attacking in the next demo, you have like a variable. So for example, you can have window ABC and 123. And then when you alert this variable from the HTML, this will alert 123, right? So this is with no context isolation, which is the insecure setting, right? And when the context isolation is set to true, the difference is that this is going to be undefined, right? So if you do window.abc equals 123, and then you try to alert that from the renderer, right, it's going to be undefined. So this is what the isolation does. Now, why is this important, right? So you have an XSS, you can use it to attack the preload script, right? So this is the preload script, and it has like a check for index of something, right? If index of something is different than -1, then it will open this with shell open external. Now, shell open external is generally safe as long as the URL that you pass into it is HTTP or HTTPS, right? If it is something else, then there could be problems, right? It could be code execution. So in this example, we are redefining the JavaScript function index of. So we can, even though we cannot like directly change the code of the preload script, we can redefine how the index of function works in JavaScript. So it always returns lead, and then we can bypass this check and gain code execution that way, right? So this is what this is doing. It is exploiting an XSS, right? So we have script, and then we have a link, and the link is a file URL that when clicked will result in code execution, right? So yeah, when there is no context isolation, XSS on the renderer can access and modify JavaScript prototypes used in preload scripts to be able to access more privileged code and bypass certain checks, right? So this is pretty cool, right? It leads to interesting vulnerabilities. Now that we have everything set up, right, assuming you have downloaded the app and all that, now you can go back through this as you try to do this exercise. You will notice here there's a filter, so this should be set to true. Now this is like requiring Electron, and it is defining the safe protocols to open using shell open external. So shell open external is a sink, right? We saw the concept of sinks before for XSS. So shell open external is a sink specific to Electron applications, right? So whenever in an Electron application you see shell open external and you can send file URLs to this, then this is a security problem because it can lead to code execution when users click on stuff, right? We define the safe protocols, and then there's an event listener that is running this check, right? So it's checking like, okay, this is an aid node, it gets the link from the target, right? So this is all like the JavaScript way to do this. It has the safe protocols defined, right? So problem with this. And then it's checking that the link.protocol, which is also the correct way to check the protocol in a link, right? Instead of parsing it yourself with a regex or something, this is like the proper way to do it. If the protocol is not safe, then it will open it into shell open external, right? So that is how that looks. And then you can like send a link like this, right? So you can do file and then 127.0.0.1 Electron remote code execution.jar. Now Java files will always run without warnings on Windows, so this is why we're using jar. So we get like true code execution, right, without warnings. And then, so basically you would send a message to somebody running the Electron application, hey, look at this, and file something, and then there's a linkifier, right, that will turn this into a link. But here, when the user clicks on the link, we get this link is unsafe, right? So we need to bypass this security check in order to get shell open external to open this file URL, right? So to do that, we need to take a look at the preload script and modify this, right? So we can do image source X on error alert one, or on error, and then array prototype index of function, return lead, right? And then when we send payload like this, and then the hey, look at this, the same that we said before, what we're doing is because we are changing the way the index of function works, we can make this always open every link under open shell open external. So this will result in code execution without warnings in Windows, right? So this is how this looks, right? And you can try this on the JavaScript console as well. So you can do save protocols, index of HTTP, save protocols, index of file, and you can see it's always returning lead, right? Because we have modified the function using this payload here, like array prototype index of function return lead. So from this point onwards, the index of function in JavaScript has been modified, and this way we can attack the preload script and gain code execution every time, right? And yes, this was found in a real test, right? Enough theory. Now let me share, where is this? My other VM. So for this one, you're going to need a Windows VM, right? So this is the app. I think you can see, yeah, you can see my screen, right? Is that big enough? Let's see, how can I, oh, maybe properties? I can make it a bit bigger, maybe. Okay, so is that better? Okay, cool. So I'm just doing here, we will have a break now after the demo so that you can try this, and I will check if somebody still has problems with access. But now, because everything is going to be recorded and you already have the recording from the last time actually already on the portal, you will be able to do this. So I'll get back to you guys with the access problem. So we do npm start. Now again, first you need to do npm install, but I already did that, so I can do npm start directly. This will open the application. Now let me see if I can make this a little bit bigger. Doesn't seem to have, oh, it's making this bigger, but not the actual text on the page. Okay, so that's not super helpful, but anyway, so this is the vulnerable application, and what we're going to do is we're going to do first the hey look at this, right? So I'm pasting this hey look at this, and I'm sending a message now because there's a linkifier, and this is very common in applications. We see this now. Since it's bigger below, I'm going to go here, and now if I make this bigger, oh, now it is working. Okay. So I'm just making this a little bit bigger for you so that you can follow better, right? So we send this, hey, look at this, right? And there's a URL. It's a file URL. It's dangerous. It is a Java file. So this will give us code execution in Windows without warning. So when I click on this, there's still a check that we need to bypass, right? It's saying this link is unsafe, right? So this is what we need to bypass, right? So, but in here you can see that, yeah, and I think now if I do zoom in, no, okay. Anyway, so in here you can see that this was linkified, right? But we need to bypass this. So to bypass it, we can do this, right? So if we do image source X on error and then array prototype index of function lead, now the index of function will be different, right? So we can also, I think, let me see if I have the preload script here open, right? So we have save protocols, right? So if I do save protocols here on the console, I can do this, right? And then I can do save protocols, index of, and now let's put here, index of, and instead of link protocol, we are going to put here, oops, US keyboard. Let me see if I don't remember now. Where is this? Okay, let's be lazy and just copy it from here. So if I put index of HTTP, yeah, this is because of the parentheses, right? So we get 0. If I do HTTPS, we get 1. If I do file, we get -1, right? So if we do, I know this is a little bit small, but I'm not sure now how to make it bigger. So what I'm just trying to say is safe protocols index of file is what is returning -1, right? So this is what we're trying to bypass. So if we change the index of function to always return lit, then, right, so here you can see this link is unsafe, right? So we are falling into this condition, right? There's this alert, right? This link is unsafe, right? But if instead of this payload, we try this payload, now we are changing the index of function. So if I click on this, now we are no longer getting the security warning, and we are getting code execution without warnings directly, because this is a Java file, so it requires no warnings, right? Now, for this to work, you need to have, because I think this is not on the slides, so you need to have a share called Electron on C, right? And now you go here and you go to properties, sharing, and you just share this, right? So yeah, and you can get some of these VMs for free for Windows, or you can use a Windows VM if you already have one. But yeah, you just need to enable sharing and create a share, and then these should have the remote code execution jar file. So that will give you access. So with this, give like 5 minutes for this because we still have more demos, and I'll check the remaining people with access problems now. So yeah, so just go back to, let me share, just go back on the slide to here, attacking preload scripts. Give this one a shot, and I'll keep troubleshooting if anybody has still access problems. And in the meantime, if anybody has any questions with access or without access, just let me know and I'll be happy to answer them. I talked about at the beginning that the renderer process can send messages to the main process and the other way around, right? So with this, even when the main process is locked down, sometimes we can exploit functionality on the main process from the renderer, right? So for this exercise, you need to use the vulnerable3 application. Now, again, just email admin@70security.com and I'll give you access to all this completely for free, so that's no problem. So you will need that. And then the way this works is the main process, right? It's called, in this case, typically developers will call it something like IPC main, and then you need the main process to declare some events, right? So for example, declare get update, right? And then here we have an event, it's called get update, and then one of the parameters is the URL to get the update, right? So then it does console log get update and the URL, and then it tries to download this URL, right? So this is what this is doing, like a quick glance, right? So this is a requirement, right? So the main process has to have some IPC listener for this kind of attack to work, right? So we need the main process to expose something to the renderer process, right? And now the renderer process needs to expose this IPC to XSS, right? For example, using the preload script, you can do something like window, Electron send, and then do IPC renderer send, right? So if this is exposed, then we can use Electron send to access stuff in the main process, even though this would normally not be possible with the IPC. We can use now XSS to access functionality on the main script, right? So this is pretty cool. So in this case, this was an application that was exposing an IPC that was trying to get an update. So it is a little bit simplified from what the application was doing in real life, but it is quite similar. So here you have the link to the proof of concept. So basically, we need to have like a script or some XSS payload that is going to get the update. So we have to do Electron send get update and then the URL from where the actual reverse shell code is going to be. And then we can, with this, give a fake update to the application and then gain code execution using this, right? So this is one of the other exercise we have in the course, and you have now access to this one for free as well, just for practice, which is quite nice, right? So JavaScript on the app using XSS can invoke functionality of the main process, which is more privileged, using IPC. And IPC stands for inter-process communication. So basically sending a message, right? So if you're familiar with Android, sending intents from one app to another. So this kind of the same thing, sending a message from the render process to the main process, right? So that is what we are attacking, because usually the functionality that is exposed to the user is going to be on the render process, right? So now another thing to look at is the middle click, right? The middle click is going to bypass click events, right? So here we have all these checks that we saw before, right? With Electron, and then it's checking if the link is safe or not, and it's doing so correctly. But this is using the click event listener. So when we do, if the user, instead of clicking, does a middle click, it will bypass this check, right? So this is another possible way to gain code execution. And another thing is that we can gain code execution sending an IPC to Electron using this, right, with the middle click, right? And this is a cool payload to do this for Windows, right? So you can do, for example, start command and then dash K so that you see the actual command, right? Normally you would not want the user to see the command, but now for demonstration purposes, we want to see the command so that you see this is working, right? Yeah, and this is basically giving us command execution. So you have all these links, right? Yeah, and this is the source code payload, and this is more or less how it will look on the vulnerable application, right? So you send this Windows 2 and then send message, and then you click on the link and you get all this stuff, right? Now, another thing is exploiting the lack of context isolation, right? So if you have no context isolation and you have Electron open in browser, shell open external URL, then this is another way to gain code execution, because normally you would not have the ability to do shell open external URL from an XSS on the renderer, but if the preload script does something like this, then you can, right? So this is like another way. So you can have like different event listeners like this on the preload script. So the preload script is always very important to pay attention to, because sometimes it can give you interesting attack surface, right? So you have Electron listener, Electron listen, Electron send, and stuff like this you can exploit, right? So um, we will check this, right? Now you should try to find these vulnerabilities by yourself. So just pause the video, read this, and try to find the vulnerabilities. Now I'm skipping a little bit through this because we are kind of short on time. But basically, here is the code, right? So just spend a few seconds looking at this, and if somebody finds a problem, you can type in the chat. So I'll give you only a few seconds because I still have one demo left. Does anybody see the problem with this? Nobody? The workshop um, channel? Nobody? Okay, so I'll tell you. So basically, this is doing get update of the URL, and then it just downloads this, right? So then there's another event, will download, that will fire when this happens. And the handler for this, you can see it here, right? So this is downloaded this URL, and then it gets the file name, and it gets the downloads folder and it saves it there, right? It says download path is going to be the downloads folder of the application of the system, and then whatever file name was in the URL, and then it will set that as the safe path. And after doing all that, here you will see that this is assigning executable permissions to the update file, and then it runs it with this, right? Require child process exec file. So this is running the actual update, right? So what can we do with this? We can basically, with an XSS, give a URL that has our own code to run, and then the application will download it, give it executable permissions, run it, and then we have code execution again, right? So this is a cool way to gain code execution. You would normally look for the main section of package.json, then that will lead you to see that IPC main is there, that there's a get update event, there's a will download event, like using the file name from the URL, right? So we control the file name and the extension of the file, very important for exploiting this. So it will be downloaded there. And then here we have assignment of executable permissions, and then it just executes the file and all that, right? So this can lead to XSS, and we have like how to exploit this here. So I'm just going to do it now in the demo, and it will be more beautiful maybe. But this is the main idea, right? So we do Electron send, get update of a URL where we have a reverse shell. Of course, for this to work, we need a netcat listener on another terminal. So we just do that netcat and listening on port 444, which is the shell port, right? And then after all that is in place, we can try the link and we will get code execution. So I'll show this now. Yeah, and then because there's a lot of console log on the same terminal from where you run npm start, you will see like how it's getting the update, the download path, and received bytes and all this, and then it will run the update, right? So with this, you should be able to get a shell, and then you should be able to run commands like id, ls, and all these kinds of stuff, cat password, and so on. So I'm going to show the demo for this. Let me see. I'll share. I need to share the VM. This one. Okay, so let me see. So now I need to close vulnerable one, and we need to start. I think it's vulnerable. Yeah, it's this one. So we ran npm start on vulnerable 3, right? And here we have, I mean, you already have here like a few other attacks and stuff, right? So in this case, we can try, for example, let me see here. So we're going to do the Linux reverse shell, right? So I'm just going to copy that and paste it here. So can you see my screen? Zoom in. Is that big enough? Yes. So we need to send this link, right? And another important thing for this to work is that we need some netcat listener, right? So I need to hit enter on this, right? And now we have netcat listening here. And now I'm going to click on this. So I'm going to send message. And now if I click on this here, so you can see the script and Electron send get update, and then getting the shell like this, right? So this is what this is doing. So now I'm going to click on this, and we get this screen, right? But the place we need to look at now is here, right? So we can see that we got something back. I can do ID, I can do ls, I can do cat etc password. So I have a reverse shell on the application, right? And this is all because we got problem in the source code, right? So we had the preload script is exposing Electron functionality, right? So we have this Electron send stuff which allows us to send events. The main process has this listener, right? So there's an APC main, right? You can see it here, IPC main, get update, right? And this is what is getting the update and so on. So we can give it our remote or reverse shell, show you here, right? Which is basically a standard shell one-liner, and this will get executed, right? So with this, I think we're out of time, but maybe you can try this one. Or you can try this one on your own, and if you have any issues, you let me know. And yeah, with this, I think this is the end of the thing. Well, we are running this course in November. If you are interested for CIFCon, so there's a link for that on the slides because initially this was for a webinar for them. Yeah, and if you have any questions about this or anything else, because we are the 2-hour mark, so yeah, you can just try this last demo and let me know if you have any questions. Okay, Sam. Okay, velocity 9 got the problem sorted. That's good. Okay, and somebody else also has it working. So does anybody have any questions that you would like to have answered about the workshop, about any of the concepts I covered, about anything you want about life? Any? No problem. Sure. Well, the ones I have shown are okay. I see it now. Yeah. The ones I have shown in this workshop are more focused on Electron. In the course, we cover other things that are also applicable to other desktop applications, no matter the platform. Like things like man in the middle, you always have to man in the middle, any application that you're testing, if it's Android, iOS, Mac, Windows, Linux, you have to man in the middle to see what's going on to test that. So that would be applicable to everything. Local leaks in the file system is covered in the course. We didn't cover it in the workshop itself. That would also be something that would work against all desktop applications, but we didn't cover in the workshop. But what we did cover in the workshop that would be applicable to other JavaScript applications, even mobile applications, would be the fact that the stuff that you can do with XSS, right? Because you can have another application that maybe is not written in Electron, but somehow it's written in some other JavaScript platform. Or, for example, in the case of Android and iOS, it is quite common to have apps written in Ionic, PhoneGap, React, Apache Cordova, right? So all these platforms are JavaScript platforms, and in all these platforms, you can use XSS sometimes to read local files, right? And then send them to an attacker. So actually, we have some examples about exploiting that in mobile course as well. So those would be some scenarios that of stuff that we have looked at today where it would also be applicable to other platforms, right? So in general, like anything that is written with JavaScript, you could use many of these techniques. Even if you are testing a web application, for example, a lot of the techniques that I've covered today about how to turn XSS into code execution will also work against Node.js web applications, right? In many cases. Now, you're not going to send a link to the server, so some of the attacks are a little bit different, but you will have always in a Node.js application, you always have kind of node integration enabled, right? Because so all the attacks about how to turn an XSS into code execution in Electron are all techniques that will be useful for you as a web pen tester when you're testing a web app to try to turn any XSS on the server itself into code execution, right? So um, it's kind of weird, right? Because it's hacking desktop applications, but really the techniques that you learn can be, applicable to so many other fields, like even web applications, mobile applications. It just depends. Anything that's written in JavaScript pretty much is affected, but there's other things that even if the app is not written in JavaScript, that a lot of the techniques that we cover in the course itself will also be applicable to them, like all the stuff that I talk about Frida, for example, right? So Frida is a tool that is completely free and it works on all platforms and it allows you to see and modify what the application is doing at runtime, right? So we have a lab about using Frida against Electron applications, but you can use Frida against any application. You can use Frida against Android, iOS, Mac, Windows, OS 10. Doesn't matter, works on everything. Okay, so does that answer the question, or would you like me to elaborate more? Yeah, that serialization can be a problem sometimes in Java applications. But of course, you always need the planets to align, right? You need like somehow be able to send the user some kind of input that is going to be deserialized somewhere, right? So it's not always possible, but this is another possible vector. Actually, this reminds me of the kind of equivalent to serialization against Node.js applications that we actually cover in the web course, which is the JSON, so the prototype pollution, right? So in this case, you would give like JSON to an application. And then if this JSON is being, depending on how the application is built, like being cloned in the wrong way and stuff, then this will also turn into, you can, for example, become admin or something like this, right? So we have some labs for that. So that would be similar to deserialization in Java. And you can also do this against Electron applications, but again, this you need to plan it to align, right? So you need to somehow be able to send an object, or it's the same with PHP. Like it's unserialized is bad in PHP, right? When you use it on user input, but you need the application to do it to be able to exploit. So you need the plans to align a little bit. But yeah, all these attacks is something that I have seen, and they can be when they happen, they can be really bad. Another example would be in Python pickle, right? So if you have an object in Python that is being serialized and then it's being deserialized using pickle loads, right? Then that can also be like code execution. There's like multiple ways. It's not like specific to Node.js, Electron, or Java. There's like each platform has its own little things, but it can affect like web apps, it can affect desktop apps. It's all those issues. The serialization is similar, but in JavaScript applications, typically more common would be like the JSON thing with prototype pollution, would be more normal, right? But yeah, it's all similar. I'm not sure. Did I answer the question, or you want me to? Sure. Yeah, if this is recorded and then put on YouTube or whatever, and you see this later, just email admin at cybersecurity.com for access, and that's fine. We can give you access to all this. It's no problem. All right, really? Yeah, I mean, Philippines was Spain, right? A very long while ago. So I know there were some. Yeah, I know there were some problems. Well, with all this colonization, there were a lot of barbarities done. But so I'm sorry for all that. But yeah, there's a lot of Basque surnames in Philippines and actually in Venezuela and other kind of ex-Spain countries. Like countries that used to belong to the empire but no longer do. It looks like my surname is popular in some of those countries. So it's interesting that a Basque surname is most popular, I think, in Venezuela. So yeah, this is, and yeah, as I was getting the emails, it was interesting to me. Like I'm seeing like English names but Spanish surnames. So it was kind of interesting combination. Okay, right, right, yeah, 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 yeah. Yeah. Well, I think. Yeah, there's a lot of Basque surnames everywhere. Well, this is, of course, it's like Spanish. It's part of Spain, right? But in the case of my surname specifically, comes from the north, from a north region of Spain where Basque language is spoken. So this is like completely different from other Romanic languages, right? So if a Spanish person or a French person or an English person tries to speak to a Basque person in Basque, they would not understand anything because it's a language from before the Romans, right? They were not conquered in more than 2,000 years. So they were like hiding in the mountains and stuff. And they have all these like crazy sports about lifting stones and so on. So, so yeah, I heard some stories about my great grandfather lifting, lifting stones and doing stuff like that. So yeah, but yeah, I saw this. There was some nice person. I think he was like history did not speak badly about him. He tried to be fair or something in Philippines, and he was Legazpi, I think, in the early colonization, and he tried to be a little bit fair. I'm not sure how true that was, but at least he tried to do good, I think. And the missionaries, I think, were pretty good because I remember the from what I remember from history, right? Like there was something like the king told the Jesuits, like, you have to teach these guys Spanish, and they said, no, we are here to give them the gospel and so on, right? And to teach him about teach them about God. And what we are going to do is we are going to learn their language, and we're going to teach them how to cultivate the land and all these things. But we are not going to teach them Spanish. We are going to learn their language, right? So the missionaries, I think did some nice work, and this is why maybe some people in the Philippines are still so Catholic, right? Because of these kind of nice people. You also get the bad side of that, of course, but yeah, 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 no problem. Yeah, yeah, I'm from Spanish origin, but I'm actually like Spanish, but it's funny because I have a Basque surname, but when I speak in Spanish, I have a Catalan accent because I grew up in Valencia, so in the Valencian community. So it's always strange when I speak to a Spanish person. They know my surname, which is Basque, so they're expecting a Basque person, but then I have this Catalan accent, so it's all confusing, right? So So yeah, it's all fine. Anyway, thank you for accepting the workshop, and hopefully this was interesting. And if somebody wants access to this workshop, it's all free. So just email admin@serenity.security.com. I'll give you access. That's fine. So thank you for coming. Awesome. Yeah, looking forward to the next one then. Sure. Uh, a bind shell. Uh, yeah, I think what he means is uh, no, no. I think what he means is because I showed the example of the reverse shell, right? So because you're attacking a desktop application, it's very unlikely in principle that the user is going to have an IP that is publicly exposed to the internet, and then it's unlikely, right? So the reverse shell would be like more normal and have a much higher likelihood of success, right, than a bind shell. I think it should be possible because you can run any command that you want, right? So you can still do a bind shell, but it would be much less likely for it to work. I mean, because you have code executions, you can run any commands you want. You can do like a bind shell or a reverse shell. You can do anything you want because you can run any command you want. So anything you can do in Linux will work, but the reverse shell will have a much higher chance of working because most people are going to be behind NAT, or you could have maybe you only have IPv4 and the guy is on IPv6 or whatever. So all this kind of stuff you get around by with the reverse shell, right? So if you do a reverse shell, when you explode the code execution against a desktop application, that's the most logical way to do it because it's the approach that will have the higher chances of success, right? If you want me to elaborate more on that, just try again. But hopefully, was that clear? I think what he means is when I showed the demo, right? It was a reverse shell, so the attacker is listening on a port on his local computer or server, right? And then the shell flies from the user on the desktop to the attacker server. So this is a reverse shell. So that is what is most likely to work. And the bind shell, which is what the question was about, would be the reverse, right? Like the desktop computer is listening on a port, and then the attacker tries to connect to the port on the desktop. So this is less likely to work because usually it's a desktop application, so the user is going to be behind NAT or something. So physically, like you cannot like reach that IP address to be able to connect to the port, right? So that's my understanding of the question. So hopefully that was clear enough. Cool. Okay, so if there's no more questions, maybe we can leave it here.